This is our second video in the series where we're analyzing different types of pressures in fluid. And in this video, we're going to look specifically at fluid pressure. Now, a fluid is either a liquid or a gas, and there are four basic factors governing the pressure within fluids. So the first factor that we have here is that the pressure at a given depth is equal in all directions. So what that really means is within a container where we have some sort of fluid, the pressure is meant to be equal in all directions. That's simply it. Now on to the next point. So for this one, the pressure at a given depth in a fluid is independent of the shape of the container in which the fluid is held. So what that really means is, even though it's sort of self-explanatory, so let's say we have some sort of shape like this. So that's representing our shape. And we're looking at the pressure at whichever depth we pick. So we could choose right there. We could choose, let's say, right here. The pressure at any of those depths, regardless of the shape, we're saying that it will basically be the same. So this one is sort of intuitive, where the pressure acts at right angle to the surface. So regardless of what our shape is, so let's say we have this here, so the pressure will be acting normal to each of these surface type, and it will tend to try and do that even for curved surfaces, irregular shaped surfaces. So that's the third factor, and on to the final factor before we look at a few examples. So this final factor is sort of complementing the first one, whereby when a pressure is applied to a fluid, this pressure is transmitted equally in all directions. So this here complements the first one, where we looked at the pressure being perpendicular and in all direction, and we're saying that it's gonna be also equal in all direction. So we're going to look at a few worked examples now to sort of consolidate this and to sort of get used to working with the formula as well. So in our first example here, we have a tank container. So a tank contains water to a depth of 60 mil, and we need to calculate the pressure. Now you might be wondering, where is the force, where is everything that we need to do this calculation? But it's fairly straightforward, and as soon as I go through the formula with you, you will kind of see what's happening. So let's have a look at this example to sort of cement everything. So we have that a tank contains water to a depth of 60 mil, and we need to calculate the pressure. Now we have the pressure to be calculated at different depths. So the first depth is 350 millimeters, and we also have another here where we need to figure out the pressure at the base of the tank. So there are three main factors to consider here when we're looking at the pressure in this case here. So the first factor is to consider what the density of the fluid is, and the symbol for density is rho, so that's the Greek symbol, and in terms of its unit, it's kilograms per meters cubed. So that's the first factor. The next factor that we need to consider as well is gravitational acceleration. I'll just write that as gravity, and that will be represented by the letter G. And the value that we use for gravity is 9.8. We're just going to use 9.8 in this example. And the unit for gravity is meters per second square, because it's gravitational acceleration. And then now the final factor that we need is basically the height of the fluid. So we need the height, and the symbol H. And of course, the unit for height is going to be in meters. So let's have a look then at part A. So our formula is our pressure is equal to, so this is the rho symbol for density, multiplied by gravity and multiplied by height. So those are the three variables that we have to multiply. And in this case, the value for density, since it's density of water we're looking at, is going to be 1,000. So 1,000 kilograms per meters cube, multiplied by gravity, which is our 9.8, and it's going to be multiplied by we're looking at the depth of 350 millimeters. So we're just going to convert that now into meters because of our previous unit for gravity, which is meters per second square. So we have to convert our depth here to meters, which is going to be 0.35. So our final answer here, when we multiply out, we get 3,430 pascals. And if we want to write that in kilopascals, divide by 1,000 and we get 3.43 kilopascals. So that's part A. Now, in terms of the base of the tank, let's just go back and look at the question. So the question here tells us that the tank contains water to a depth of 60 millimeters. So really all that will be changing here is our height. So if we go through this calculation, then same formula. So we have our pressure equals our density times our gravity times by our height. So our density remains the same, gravity remains the same, and our height is now 0.6, which leaves us with this 5,880, and that's pascals. But again, if we want to convert into kilopascals, then it's just 5.88 kilopascals. There you go. So this is a pretty straightforward example of working with our formula. Let's look at another example where perhaps this time around we might need to be more creative. So we look at a second example then. So in this second example, what we still have a storage tank here. So our storage tank, it contains petrol, and the height of the petrol is 4.7 meters. Now this time around, we're given the pressure. It says if the pressure at the base of the tank is 32.2 kilopascal, then we need to determine the density of the petrol. So let's have a look at this one. Now I typically start by writing out the original formula. So that's our pressure is equal to density times our gravity multiplied by our height. And of course, what we're trying to find here is what's our density. So if we were to rearrange this formula then to get what our density is, so remember that rho symbol is representing density. So density would just be our pressure divided by our gravity multiplied by our height. And that's just rearranging formula, quite straightforward. So let's go ahead now and insert our values that we have into this formula to find what our density is. So then our density is equal to, so the value we got for pressure is 3.2 kilopascals. So we need to ensure that we write that out in full. So it's 32 kilopascals actually, so 32.2. And we're going to multiply that by 10 to the power of 3 to convert our kilopascals into pascals, and then divided by our gravity, 9.8, and multiplied by our height that's given, which is 4.7 meters. So our final answer here for density is 699, that's kilograms per meters cube. So that's representing the density of the petrol. Now, this is the second video. We're going to move on to the next video where we look at Archimedes' principle, and we're going to do the same where we analyze the concept and then we look at a few examples. And of course, I would love it if you could subscribe to the channel if you haven't already, and please give the video a thumbs up. Now, I'll see you in the next video.